Before we begin today's paper presentation session, let us take a moment to acknowledge the prestigious National Conference on Innovations in Computing and Smart Technologies under this session, which is being conducted.
CST serves as a premier platform for researchers, academicians, and industry professionals to showcase their innovative ideas, share insights, and discuss emerging trends in computing and smart technologies. This conference fosters collaboration, encourages groundbreaking research, and paves the way for future advancements in the field.
Through this conference, we aim to highlight the cutting edge developments and the real world applications that can shape the future of technology. Today's Track 3 session is a testament to the creativity and dedication of the young researchers pushing the boundaries of innovation.
With that, let's move forward and begin today's paper presentation session.
Good morning to everyone present here. It is with a great honor that we welcome our esteemed judges, respected faculty members, and enthusiastic participants to the track 3 of today's paper presentation session. Research and innovation are the pillars of progress, and today we are gathered here to witness the young minds presenting the groundbreaking ideas that have the potential to make a difference.
We are privileged to have with us Dr. Shanu N, our track chair, whose expertise and insights will guide us through this session. A special note of appreciation to our faculty in charge, Ms. Nasseena N, Assistant Professor, Computer Engineering Department, for her unwavering support in making this event possible.
Today's session will feature five research presentations, each offering a unique perspective on emerging technologies. After every presentation, there will be a dedicated Q&A section allowing our judges and audience to engage with the presenters and explore their research in greater depth.
That, let's begin the first presentation of the session. Kicking off today's session, we have Hilalkalam and team presenting paper ID 45G on Autospaxe and IoT-based smart parking application. In an era where urban congestion is rising, smart parking solutions play a vital role. We now invite the team to share their research.
Good morning, all. We are here to present our project named Autospace. Can anyone hear me? Sir, hello. Can you hear me?
Yes.
Yes, we can hear.
So let me introduce our team: Adarsh, Advait, Gogul, Hilal, Pranav. First of all, I am moving to the abstract of our project. The increasing demand for parking in urban areas has led to congestion, time wastage, and inefficient parking management, particularly in densely populated cities. This project aims to develop an IoT availability information, leading to frustration for users and suboptimal management for parking owners. The project proposed a smart parking solution using IoT technology to automate parking management, improve user experience, and optimize parking space usage. The system consists of four main components. First, the super admin website, then the admin website, the user mobile application, and an IoT enabled parking management hardware. The users can search for nearby parking space, reserve multiple slots according to their preference, and an automatic entry or assist using number plate recognition. The detailed view of parking history will be viewed in their application and they can navigate to the selected location. The system consists of four main components: the super admin website, the admin website, user mobile, and then the IoT mobile parking management system. Then, moving to the problem statement, to develop an efficient urban parking management system using IoT technology to optimize the use of available parking spaces, reduce traffic congestion, and enhance user experience. Then, moving to the objectives of our project, develop an automated parking management system using IoT sensors, which provide a real-time updates on parking availability to the users, which offers easy property registration from an property owner by providing a dedicated website for owners to register. The integrated servers, the motors, and the camera to detect vehicle and provide automated entry and exit. Moving to the IoT-based market system in 2016 International Conference of Internet of Things application. The methodologies are the parking sensors. The sensors such as infrared, passive infrared, and ultrasonic sensors are deployed in parking spaces to detect vehicle presence. These sensors are connected wirelessly to a Raspberry Pi through the ESP8265 Wi-Fi module. The processing unit, the Raspberry Pi serves as the processing unit that collects data from the sensors and forward it to the cloud.
एग्जाम करेंगे मेरे बाप
It uses MQTT protocol to communicate with the cloud server for data transmission, which is designed for a low bandwidth, lightweight messaging. The advantages are we uses a cloud integration which utilizes cloud computing for scalable data storage, which is and also a cost-effective way for this. The disadvantages are the system mostly relies heavily on the cloud infrastructure and internet connectivity. Any disruption in internet service can render the system down. The security concerns regarding these are storing and transmitting users and the system data over the cloud introduces potential security risks, including unauthorized access to data. And also some hardware limitations are also there. The sensors and the Raspberry Pi units used for processing data have limited capacity, which may trigger some problems. Moving to the next paper, which is the Spark, a novel application to provide real-time parking solution. The parking spot allocation. Upon arrival, the drivers register their vehicle details, which are securely stored in Raspberry Pi database. A dedicated RFID card is issued to drivers for future use in the system. Real-time data and parking information of the available space information can be accessible through the Spark Android app and website. The drivers can check parking availability remotely and navigate to their assigned spot using Google Map integration. The advantages are with RFID authentication and automated barricades, the system ensures that only authorized vehicles park in allocated spots. The integration of Google Map and the mobile app allows users to easily navigate to their parking spots. Some disadvantages are we are using the RFID dependency. The system heavily relies on RFID technology, which might become problematic if the RFID card or the token is lost or damaged. Revoking certificates requires reissuing them to entire batch, which can cyber something. Then moving to the next paper, which is the International Journal of Computer Application. The methodology introduced here are the real-time parking space detection. In here, we uses the infrared sensors detect whether a parking slot is occupied or not, or sensing the presence of vehicle. When a vehicle is detected, the sensor returns to low voltage signal. Otherwise, it turns high voltage signal. The reservation, the users can reserve the parking spaces through mobile or web application, and there is a QR code which generated a unique QR code which can be used in the entry and the exit. When I am heading to the existing system, the Eco Park. The Eco Park is a smart parking system that aims to provide low cost and a sustainable solution for efficient parking management. Then the iPark system, which introduces an IoT-based parking system, which helps the user to find and reserve parking slots. The limitation of these existing systems are the lack of real-time information, no automation in vehicle entry exit, manual processes for payment and slot allocation, and also limited payment options also there. No dynamic slot allocations. Here are the proposals to overcome limitation. We implemented the IoT-based sensors to detect real-time parking slot occupancy, introduced license plate recognition for automatic entry and exit using a OCR technology, developed a mobile application that allows users to pre-book slots and receive real-time updates on availability, offer payment options through the application, reduce the need for manual transaction. Heading to the system architecture. So here, the vehicle can be found and the sensor trigger the Arduino and the Wi-Fi modules, which also controls the servo motor, and the backend is acted here as Spring Boot application, and the data is stored and retrieved through the cloud database, which among the super admin portal, the mobile application, admin web portal, and the official web portal. The hardware required are the processor Snapdragon 700 series or equivalent. The memory requirements at least 4 GB RAM or higher. Storage minimum 32 GB internal storage necessary. And the sensors, the PR sensors, the camera and the Wi-Fi modules, Arduino Uno, servo motors, LCD displays, and the breadboard, and some jump wires. The software requirements, which are operating system, Android 9 or higher, the Android Studio, Arduino IDE, and the Spring Boot, Intel IDE, and MySQL Workbench, and the OCR technology, which we use Tesseract for this purpose. And we are describing about the modules. Integrates hardware, software, and IoT to provide an end-to-end smart parking system. Allows parking IoT owners to register properties, set roles, whether it is for hardware or without hardware, configure slots and floors, and manage payments. And then the super admin can manage the applications. He can accept or reject according to his preference of the registered property, and then move to the admin website. The admin can enables the monitoring of the available and the occupied slots, provide user information, booking history, and options to impose fines. Then the user, who can accommodate vehicles in the parking slots reserved, the real-time parking availability, slot pre-booking, time extension, and automated entry-exit. And he can also subscribe monthly according to his plan. The IoT hardware integration. We use the Arduino and the Wi-Fi modules for the communication between the database and the backend. And we use object detection sensors and step motors for automated barrier operations. The data flow. for the level 0, and then the moving to the admin data flow diagram, and the data flow of the user who can register, login, and fully enjoy their functionalities, and the data flow of the hardware. And this is the circuit diagram we used for connecting the hardware. And finally, our system features some user registration seamlessly, and the UI user designs for mobile and web interface which actively promote users to engage in their day to day with the traffic allocations. Overall, the system and the hardware work seamlessly for effective user functionalities. In order, IoT devices like sensors, cameras, and microcontrollers and the servo motors are work equipmentally and mount cameras at the entry and the exit gates to capture the vehicle plates. Set up a Spring Boot application for handling user, admin, and parking data. Design the database schema to store the parking slots, the user data, the vehicle info, bookings, and payments. Develop the user and admin interface for interaction with the system. So the admin can allocate the slotting positions accordingly, and the implementations we used here are the users can extend the booking time with an button click and view nearby parking spots and get an easy navigation to the parking floor, ensuring a user-friendly and efficient experience. The admin interface will feature an intuitive login and dashboard, allowing the admins to monitor parking slot occupancy, booking history, and user details. So that's how our implementation are done. Some images of our super admin website, and this is the authentication of the admin login page. This is the dashboard of the admin, the profile section, the profile history, the number of allocated vehicles, the slot monitoring features, and this is the applications. We can navigate our current position to the allocated parking area, and this is the listed nearby parking slots. The user can select the vehicle type, the starting and the ending time, and also a fare charge is also introduced. After confirming the slot, we can confirm the payment, and this is our official website where someone can register their property. And we faced some issues, challenges in the hardware integrations, the smooth communication between the Arduino sensors and the Wi-Fi modules, which also extensive the productivity. The future scope of our project is just integration with the smart city infrastructure, expansion to electric vehicle charging, enhanced security features, and advanced payment and subscription options. In conclusion, the IoT-based smart parking system demonstrates how technology can transform the traditional parking experience by improving efficiency, convenience, and sustainability. It serves as a scalable and adaptable model that can implement in the urban areas worldwide. Addressing the growing demand for smarter and more efficient parking solutions, this project not only contributes to technological innovation but also fosters a positive environmental and social impact, making it a valuable addition to the realm of smart city infrastructure. We are present on the EduTech AHL conference. These are the publication details. to the reference page. These are the reference we gathered. That. Thank you. Thank you, sir. Sir, any questions regarding this?
Yeah, good others. Congratulations, you have done a wonderful project. And I find an end-to-end solution to the parking problem. Just I'm asking you certain questions to fill in the gap.
Of
Can you
course, sir.
give a Can you give me a justification on the product selection that you have done? Project, the component selection.
Is is it hardware or the?
Yeah, hardware.
So, sir, we use the Arduino Uno and the ESP8286 and the PR sensors. Uh, we use a Wi-Fi module which actively communicate with the backend and also for storage. And also we integrated the LCD display in which when the user uh, appealing to the area, if he is a registered user, the LCD display will provide the user information. And if the number plate is denoted in the database, the barrier will open and he can accommodate the vehicle inside the slot. That's all.
Yeah, no, the Arduino part, Arduino and the Wi-Fi module, you could have used an ESP32 there also. Then why?
Because the ESP32 have lesser pins, uh, so we use as an ESP8266 which act as a Wi-Fi module only.
Okay. And why didn't you use LoRaWAN? Any specific reason?
Uh,
Have you heard of LoRaWAN?
no, sir.
No.
Uh,
That is also used for this low power devices for communication. So you could have used LoRaWAN also.
okay, sir.
So any specific reason you have not tried out that, right? Am I
Uh,
right?
some concerns regarding the more. So Arduino, have more resources.
No. Not to replace Arduino, but to LoRaWAN is something else.
Okay,
It
sir.
is not a substitute for Arduino.
We could use it in future
Okay.
time.
Okay. So, what were the gaps that you identified in the existing system? Existing system, I saw one of your reference paper used RFID. Another reference paper used another technology. What were the gaps that you have identified in that?
Uh, the gaps where there is no number plate recognition. We use the number plate recognition in our system, and there is no the users cannot generate an income by registering their property, and we also implemented this feature in our system.
But
Uh,
have you seen that now FASTag has been used for payment? Have you seen that?
yes, sir.
Okay. And you have used Springboard for your application, right?
Yes, sir.
Okay, anyway, nice. It was very interesting interacting with you. Congratulations and all the best. You are releasing a product based on this, or how many proceedings have you? How many publications have based on this?
So currently we have single publications regarding this,
Yeah.
and we are planning to market this product accordingly.
Okay.
We have taken some surveys in our areas
Yeah.
and find out its necessity,
Yeah.
which is very crucial. And now
Okay.
we are planning to market around the areas,
Yeah.
and uh, which will promote some seamless effective in traffic congestion problems.
Okay. Okay. Good. And all the best for your future venture. My
Thank you.
questions are over, and audience can now ask the questions. If anybody else is logged in, or to the coordinators.
That was a great discussion with the valuable perspectives. Thank you.
Thank you, sir.
Next, we have Krithika, Krishna, and team presenting the paper ID number 4 on Alertguard Helmet, a project that addresses the critical safety concerns in an innovative manner. We now invite the team to take over.
Hello, sir. Am I audible?
Yeah, you are audible.
Okay, sir. Let me just press it now. Sir, is it visible?
Yeah, yeah.
Okay, sir. So, very warm good afternoon to everyone present here. So, I'm with my group. My orders are Agnes, Elsa, myself, and Charlotte. Our paper ID is number 4, and our topic is on alert guard helmet. So the basic contents of this page include what the project is about, what are the objectives, what are the hardware components, the software components, the architecture diagram, the components diagram, and its working and its results. So, to begin with this project, let's move on to what is Alertguard. According to 2022 statistics on Motor Vehicle Department, 45% of total road accidents was led by two-wheelers. So, fatal accidents that often occur while riding motorcycles is due to poor visibility, distracted riding, or inability to react quickly to hazards. So, as a solution to this, we have come up with a helmet known as Alert Guard, which is an intelligent safety helmet designed to enhance road safety for motorcyclists. It incorporates obstacle detection, image processing for traffic sign recognition, and vehicle speed control to prevent accidents. So basically, this is just a helmet which incorporates all sorts of IoT devices, and we can detect the obstacles that come in forward or towards the side of the vehicle, and it will just give the alerts to the driver. Let's move on to the objectives. So we have 5 objectives over here. First one is to enhance rider safety. It detects moving obstacles and traffic signs in real time to prevent collisions. Automatic speed control slows down the vehicle in hazardous situations to reduce accident risk. Helmet compliance system ensures the vehicle starts only when the helmet is securely buckled. Seamless AI integration utilizes YOLO V8 and that is YOLO version 8 and OpenCV for accurate sign recognition and rider alerts. Efficient wireless communication uses IoT and Bluetooth to enable real-time data processing and alerts. Moving on, these are the hardware components that we used. A processor with Intel Core i3 or higher, memory RAM for 8 GB and above, and a storage of 50 GB. And the components that we used are ESP32 Broom board, Arduino Nano, Raspberry Pi 4, L293D H bridge with a DC motor, HC05 Bluetooth module, ultrasonic sensors, which is HCSR04, and a camera module. Software components include YOLO version 8 OpenCV, Rail VNC, which is a server in which the results from the camera module is sent to the server, Arduino IDE, and Python 3.8.10. A basic methodology for this is that it is mainly used for enhancing the rider safety, mainly to avoid accidents in advance. It is also used to fill in the technology gaps, that is to bring into two-wheelers features that are commonly available in cars. Such as in cars, we have some things called driver drowsiness detector or anything like collision warning systems. So if that concept is present in cars, so why not integrate that into two-wheelers? Urban traffic challenges, which come up with a solution to deal with the complexity of urban traffic scenario and improve rider confidence. So this is the architecture diagram over here. So here this is the helmet portion. In the helmet, I'll just show you a figure. So this is the helmet that we used. So in this we have a camera module and three ultrasonic sensors. One is over here and two is on the other side. One is on the front and two on the other sides. And we have incorporated ESP32 Raspberry Pi. Raspberry Pi is mainly for image processing. ESP32 we have used for Bluetooth tracking, Wi-Fi module for sending in alerts. So this is the view of the helmet. Uh, so this is the architecture diagram, which is the block diagram to be specific. So in here, we use the vehicle. Inside the vehicle portion, there is this Bluetooth module, the microcontroller. That is, we used not Node, we used Nano, Arduino Nano for this, for the vehicle transmission. And for traffic lights, we used image processing using Raspberry Pi. And the components diagram, this is the helmet side, which I just showed. These three are the ultrasonic sensors. These ultrasonic sensors can detect objects up to 2 meter in the front side and 1.5 meter on the sides. So these ultrasonic sensors will and when the scooter is moving, there are some suppose a person comes from the side and he did not see us, so that distance will be calculated. Up to a minimum distance of 2 meters is done in the front, and on the sides of the helmet 1.5 centimeters. So using the concept of sonar, we have developed the ultrasonic sensor device. And from this ultrasonic sensors, it is connected to the ESP32 module, which has Wi-Fi and Bluetooth integrated in it. So it's a central microcontroller in the helmet side of the portion. So it has a built-in Wi-Fi Bluetooth, but we have also used HC05 for reducing the load on the ESP Room 32 board. So using this Bluetooth module, the sensor data is transmitted over here via the Bluetooth, and then this data is then sent to the Arduino Nano over here. So this part is the vehicle part, that is from the sensor data, and the data from the helmet is sent to the Arduino Nano, which then initiates brake to the vehicle. Not completely brake, it just slows down the vehicle. Suppose some person is coming from the side, our vehicle will detect the obstacle and it will initiate a slow braking system. Now, one thing that I've forgotten to say is that before all of this, the helmet the vehicle will only start when the helmet is buckled on. So it's a concept that many of the people in India do not follow, not wearing the helmets, and that is actually one of the major causes of accidents. So only on only on buckling the helmet strap will this entire procedure will work. So the sensor data and the helmet buckling data from the ESP32 will be moving to the Arduino Nano. And this Arduino Nano will also use another Bluetooth module, which will take in the information from the past Bluetooth module. And this L2938D that will analyze what are the storage and what are the L29D is actually the vehicle, like the which controls the DC motor. So the Arduino Nano will slow down the vehicle. So this is the basic working of what is happening over here. So as a summary, I'll tell it. First part is the helmet buckling and the vehicle start. The helmet is equipped with a buckle sensor that ensures the vehicle starts only when the helmet is securely fastened. If the buckle is not closed, the system prevents ignition, enforcing safety compliance. That is, the vehicle won't start unless the helmet is buckled. Obstacle detection. Three ultrasonic sensors continuously scan for moving obstacles. When an obstacle is detected within a critical distance, an alert is triggered, notifying the rider. If the obstacle is too close, a signal is sent via Bluetooth module to the L2938D H bridge, motor bridge controlling the vehicle. That is, when the obstacle is detected, the signal is sent from the ESP32 via the Bluetooth module to the Arduino Nano, which then gives a prompt to the L2938D H bridge to prevent the vehicle from moving. The motor speed is reduced or stopped to prevent collisions. So next part is about the image processing and traffic signs recognition. The helmet's camera captures traffic signboards in real time. Using YOLO version 8 and OpenCV, the system processes the image to detect signs. Next part is receiving alerts. The after the image is processed, that is, okay, suppose you're moving on a scooter, the camera module in the helmet will detect the signboard. Suppose it's a stop sign. So the image will be processed and an alert will be given to the driver. We have incorporated audio alerts. Audio alert will be given saying that it is a stop sign to the driver. So once receiving alerts and the rider is notified about it, a audio alert is given. Visual alert is given for future purposes. So these are the images that I've mentioned before. So the results that we found out from our project is that the system consistently blocked engine ignition when the helmet was not worn, demonstrating a 100% reliability rate in enforcing safety protocols. So our product only worked only when the helmet was strapped. So that was the main thing that we wanted to incorporate in this due to the heavy load of accidents happening in India. So this was actually something that we found. We found 100% reliability rate, and this was incorporated into the helmet. Obstacle detection. The system accurately identified objects within a 2-meter range and responded within 0.2 seconds, triggering immediate alerts or automatic braking, with detection accuracy being 95%. So the obstacle detection accuracy was 95%. For image processing, we found out that we had 92% accuracy. It mainly reduced due to the situational changes, that is the environmental changes, the brightness, and everything that involved the environment. So this is what we have for you, sir. Thank you.
That was an insightful presentation, bringing attention to a crucial aspect of safety technology. Thank you for your detailed explanation.
We now open the floor for questions from our judges and audience.
Okay, hi Krithika. Good presentation. So
Thank
let
you, sir.
me, yeah. So why have you selected a USB webcam and not PyCam for recording video?
So okay, so we actually planned. We didn't actually plan for the signboard recognition. We only planned for giving alerts to the driver and just obstacle detection only. So we didn't use PyCam because it works. USB webcams actually work easily with Raspberry Pi. So signboard detection was actually not our game plan. So when we incorporated signboard detection, we used Raspberry Pi. So due to cost constraints and Raspberry Pi, we just decided to work easily with USB webcams.
Okay, that was not a good answer because PyCams are actually cheaper than this and integration is easier than USB cam. You have a module for that. Okay,
Okay.
maybe you could incorporate this as a suggestion from our side.
Okay, okay. Yeah, for futures
Okay.
purposes, we might see, but we
Okay.
didn't actually think about that in that
Okay.
broad
Okay.
aspect.
And second one is you earlier said that 2 meter from the front and 1.5 centimeter on sides. Is it centimeter or meter?
It's 1.5 meters, sir.
Meter. Okay. Okay. Then I have noted it as too low. And also you said that 2 meter and zero point 0.2 second for the alert. So can you have you calculated with what minimum speed you could avoid an accident?
I'm sorry, sir. Can you repeat the question?
If you get an alert in 2 meters at zero point 0.2 seconds, zero point 0.2 seconds it will take to alert the driver about this. Do you know at what speed you could avoid an accident? Because even if you travel at a 40 kilometer per speed, it will take 10 meter if you press brake 10 meter before a collision. And 2 meter alert means you will get an alert, still you will have an accident. So have you calculated
We
that?
just given a relative time for this. It's not.
So,
It's an average time, not like
an exact
correct.
one.
Yeah, exactly.
And regarding braking, are you controlling the brake or you are controlling the fuel for braking?
Okay, we haven't incorporated that into the real vehicle, so we have
Yeah.
just used a model for it,
Okay, fine.
using a DC motor, just to show that the wheels will move slowly, just like that.
Okay. Okay. You have used three microcontrollers. Which are they and why? Three microcontrollers I've seen in the block diagram.
So you're braking.
No, I have seen you using three microcontrollers.
Oh yes, yes, sir. Okay, okay.
Which
Uh,
are
yeah, one microcontroller is ESP32.
uh,
Next one is Arduino Nano, and we have used an ESP32 variant also, but we haven't actually incorporated that.
okay. So actually, in your project, how many are there?
We have used two, but we are planning to incorporate this.
One more.
Yeah, one more.
And
It's
that
two variant.
using that two part, is it the working model is complete?
Yes, sir. Yes, sir. It's complete. That is the helmet that we just showed. We just can show it to you now.
Okay. And the result part, I've seen 100% reliability. So what prompted you to
That
come
is
to that figure?
for the helmet buckling.
So every
Like
time you
only
buckle,
when,
you get
yeah,
a notification that it has been buckled. That is what.
no, no,
10
no.
times you tried and 10 times you got it correct.
Yes, that is when the helmet is buckled down. Only then the product will work.
Oh, so that is what you have kept in as
Uh,
reliability 100%.
yes, sir. Yes, sir.
Okay, then. My questions are over. Now the coordinators can take off.
A highly engaging discussion. Thank you for your well articulated responses. A quick reminder to stay until the end of our meeting as we'll be taking a group photo at the conclusion. Please don't leave early so we can capture everyone in the session. Looking forward to seeing you all there.
So let me please don't call the third speaker now because we have a break up to 2 o'clock. So can we continue after two?
Say 2 o'clock കഴിഞ്ഞ് break ആവുന്നു sir പറഞ്ഞു. Okay, നോക്കട്ടെ. Sorry.
പക്ഷേ 2 മണിക്ക് ശേഷം മിനിസ്റ്ററിന്റെ ഒരു
സാറിന് 2 മണിക്ക്
Please wait. Please wait. Can I- Sir, please wait for 3 minutes for discussing. Sir, please, can you wait for 3 minutes?
I can. I'm waiting.
സാറിന്റെ സ്ക്രീൻഷോട്ട് വേണ്ടേ? സാർ ഇപ്പൊ പോവാണെങ്കിൽ സ്ക്രീൻഷോട്ട് ഇത്രയും നേരം പാർട്ടിസിപ്പേറ്റ് ചെയ്തില്ലേ? അപ്പം അന്നേരം എല്ലാവരോടും ഓണാക്കാൻ പറഞ്ഞല്ലോ. അങ്ങനെ സാർ പോവാണെങ്കിൽ സാറ് പോയി ലെഫ്റ്റായി. സാറിന്റെ സ്ക്രീൻഷോട്ട് എടുത്തില്ലായിരുന്നു.
As per Arjun, we want to take the screenshot at this moment.
ബാക്കിയുള്ളവരെല്ലാരും ഉണ്ട്. സാർ ലീവ് വന്നുകൊണ്ട് കൂടുന്ന പറഞ്ഞേക്കണം.
We need to take a screenshot right now, so please stay on the call and turn on your cameras. Kindly, all of the participants, please turn on your cameras. Shikha, Eapen.
My camera is not turning on for some reason. I'm trying to rectify. Yeah, okay.
Thank you.
Thank you.
മിസ്സിനെ വെൽക്കം ചെയ്യണ്ടേ? അപ്പം അങ്ങനെയാണെങ്കിൽ മിസ് രാവിലെ അയച്ച നോട്ട് തന്നെ വായിച്ചാൽ മതിയോ? ആ. Please don't leave this meeting until the session is over. പോയി.
പക്ഷെ മിസ് വരുമ്പോ വേറെ
വിളിക്കാം. തുറന്നിട്ട് കഴിഞ്ഞാൽ പറ്റും. മെസ്സേജ് ഒന്നും കാണിക്കത്തില്ല. കണ്ടൊന്നുമില്ലേ? അവർ വെയിറ്റ് ചെയ്യും. പറയാം.
Kindly please wait for some time. I appreciate your patience at this time.
മറ്റേ ട്രാക്ക് ചെയ്യാനുള്ള പേരാക്കിയാൽ മതി കേട്ടോ. ഡോക്ടർ സബീന
Dr. Sabina K, Assistant Professor in Computer Science with a PhD and 15 years of experience. ഗ്രൂപ്പിൽ ഇട്ടിട്ടുണ്ടായിരുന്നു.
എന്നിട്ട് ആസ് ട്രാക്ക് ചെയ്യാൻ എന്ന് പറഞ്ഞാൽ മതി. അതിന്റെ കൂടെ ആസ് ട്രാക്ക് ചെയ്യാൻ തന്നെ എഴുതിയാക്കിയില്ലേ?
നോക്കി പറയാൻ എളുപ്പമല്ലേ?
അല്ല കുറെ സമയം ചോദിക്കട്ടെ റെഡിയാണോ?
Ah, yes, തുടങ്ങിക്കോ. Yes.
We are privileged to have with us Dr. Sabina K, Assistant Professor in Computer Science with a PhD and 15 years of experience. Her research focuses on machine learning, pattern recognition, and image processing.
Moving forward, we have Shikha, Eapen and team presenting the paper ID number 33G on TrackEx, a comprehensive expense tracker with a stock recommendations and tax management. This research explores how technology can help the individuals manage their finances efficiently. Let us hear more from the team. അല്ല അവരാണ് ഇപ്പൊ പ്രസന്റ് ചെയ്തത്. അവർ ലെഫ്റ്റ് ആയിപ്പോഴാണ്. ലെഫ്റ്റ് ആയി. വിളിച്ചു വിളിച്ചു വിമലിനോട് പറഞ്ഞു വിളിച്ചു പറയാൻ. ശിഖർ നമ്പർ എന്ത് ചെയ്യും? വിശാൻ അടുത്ത ആളെ വിളിക്കട്ടെ. ആണോ? ആദ്യത്തെ
The team for paper ID 33G is facing a delay and will present in the next available slot. Meanwhile, we'll proceed with the next presentation and invite them once they are ready.
സ്റ്റെഫി സാം പറഞ്ഞോ? അടുത്ത അതിഥി പറഞ്ഞു. സ്റ്റെഫി സാം പറഞ്ഞാണോ? എന്നാ അത് പറഞ്ഞു. അത് വിളിക്കും. അതുണ്ട് ഉള്ളവരെ വിളിക്കും. നീ അങ്ങ് പറഞ്ഞു.
Next, we invite Stephy, Sam and team presenting paper ID 23G to introduce us to Vipani.io, a digital marketplace for local. In a world where digital transformation is reshaping commerce, this project presents an innovative approach to bridging local businesses with technology. Let's hear from the team.
Hello, am I audible?
Yes.
Okay. So, good afternoon, everyone. I am Stephy Sam, and today I'll be presenting our research on Vipani.io, a digital marketplace for local producers and consumers. So, the authors are Agasham Nandan, Ashish Prasannan, Shreyasam Pillai, Stephy Sam, and Betty James. So, our work focuses on bridging the gap between local farmers and producers through a mobile application that enhances accessibility, communication, and sales. So moving on to problem statement. So basically in our locality, most of the producers depend on middlemen to sell their products. And this is one of the core issues we aim to address. And another issue is that the lack of direct access for consumers to fresh and locally produced goods. So currently, the local farmers and small-scale producers face challenges such as limited market reach. That is, the producers struggle to find direct buyers, so they depend on the middleman. As a result, it reduces the profit margins. So to solve these problems, we are developing a mobile application that connects local producers and farmers directly with the consumers, streamlining order management, communication, and sales to improve accessibility to fresh local products. So, moving on to objectives, our system is designed to achieve the following objectives. That is, an online platform for selling homegrown vegetables, fruits, and local products like coconut oil, chips, etc. So, we aim to empower the local producers to sell their products to consumers without any direct intermediaries. So, and another feature we are implementing is that the community building, so that the local producers can share their stories and tips to the about the products and producers to the consumers, and the consumers can also follow the producers they wish to and see their updates and post. This creates a sense of engagement and trust between the buyers and sellers. And because of this community building feature, we can establish a transparent system, and the consumers can know exactly where the food is coming from, how it's produced, and by whom. And we also aim to strengthen the local economies by keeping the money within the community itself. And we can support the local businesses rather than the large corporate entities. And we did survey on many papers to implement this project. The first one is sell and buy homegrown vegetables and fruits online using e-commerce UML algorithm, and it followed the methodology like data collection. For the collection of data, they done interviews, researches, and observation, and the login, product info, cart, delivery modules are implemented, and the for the structure they followed the UML diagrams, and we have done many survey on similar papers. So moving on to the proposed system. To overcome the limitations of the existing system, we developed Vipani.io, which is a digital marketplace, that is a mobile application that connects the local farmers and the producers directly with the consumers without any middlemen or intermediaries. And it provides an interface for listing the products and managing the inventories. And we also facilitate the direct communication between the producers and consumers using an in-app chat system. And we follow the microservices based architecture to ensure the efficient performance and reliability. And as I told earlier, the community building feature is also incorporated, which is a platform for story sharing, and the consumers can follow the producers to see their recent posts and updates, and they can also see the new sellers in town. And another feature of this proposed system is the location-based filtering. That is, the user's location can be accessed from the database, and the product's location is also fetched, and both are compared, and the distance is calculated, and based on that, the sorted listed is returned, and that is what location-based filtering is meant. And the system architecture. So the system architecture is divided into 4 layers. First one is the user interface layer. This is the primary interface for the users, and the users can interact with the mobile app using this user interface layer, or else the front end. The next layer is routing layer, that is the API gateway, and this gateway acts as an entry point for all the requests from the mobile app, and it ensures the smooth communication between the front end and back end. And the next layer is microservices layer. This layer consists of independent services for handling specific functions. The first one is product management. It handles the products listing, inventory management, updates, etc. And the next one is order service. It manages the order placement and the status updates, etc. The payment processing handles secure transactions between the buyers and sellers. And the next one is admin panel, and it provides an administrative control for monitoring and managing the whole system. The location-based filtering I told earlier, it displays the relevant products based on the user's location, and the chat and messaging microservice enables direct communication between the buyers and sellers, and the community building supports the producers and consumers to share their stories and see them, and it provides a sense of engagement and trust between the producers and sellers. And the next layer is the data storage layer, and it basically stores the data of each independent services. And these are the software requirements. They are divided into 3: platform requirements, front-end requirements, and back-end requirements. Um, Moving on to module description, first one is the user registration and login. That is, the users can register and log in to the app using their phone number. And the product catalog provides a detailed catalog about the local products and vegetables. And the catalog includes the images, descriptions, prices, and the information about the producers. And the next one is the in-app chat module. It enables direct communication between the buyers and sellers. And we integrated with Razorpay to facilitate secure online transactions. And the about the community page I told earlier, the users can see a post of the following producers and the new sellers in town, and the producers can post their stories about the products they are selling. And the users can search for products using the name, category, or location, and the shopping cart. Through the shopping cart, users can add products to their cart, view their cart, and proceed to the checkout. Uh, we also provides the customer support, and users can contact the customer support through the app, email, or phone. Then users receive push notifications for the updates, promotions, and new products arrivals, and they can also see the messages through the notifications. Um, then the vendor management, that is, the producers can manage the product listing, inventory, and orders within the app. And the implementation, uh, so we basically implemented the app using the microservices based architecture. The front end was developed using React Native, and the back end is built with Flask. And we used Firebase authentication for the login purpose and sign in. And MongoDB was used for the data storage. And these are the result. This is the login page, and this is home screen. Banner listing, that is the offers and banners. And this is the product adding page. Users can producers can upload the products with the name, description, and category, and also they can specify the price. This is the community page, and there is a seller pop-up and the seller screens. This is the interface for chat. We can view the producers and chat with them. So this is the profile page. There we can see the previous orders, then the wish list, and the helpline to support the customers, consumer support. This is the cart page, where we can see the products added to the cart, and we can proceed to the payment. So the advantages of this app, it expands the market reach for farmers and home-based sellers rather than large corporate entities. And the another advantage is the in-app chat system that can enable the direct communication between the buyers and sellers. And the another feature or the advantage is the community building feature. And users can also facilitate secure online transactions. So to conclude, uh, we identified the challenges in local producer consumer. That is, we addressed the issues the producers and consumers are facing, and we developed this app Benny.io to provide a direct, efficient, and scalable solution. And we implemented the key features like order management, chat, location-based filtering, and community building. So that concludes my presentation, and thank you.
A well executed idea that holds great potential in the digital economy. Thank you for your presentation.
We now proceed to the question and answer
Okay.
session. Judges and audience, please go ahead with your questions.
Okay. Is there any algorithm for location-based filtering in your project?
Uh, the when the user log in, we can fetch the location of the user, and it is stored in the database. And the product's location is also fetched from the product database, and the longitude and latitude of the location is fetched, and it is used to compute the distances between them. And with that, we sort the list and return it.
How will you identify the nearby customers or nearby that product sellers in your proposed work?
Yeah, it is stored in the database itself, and we use that to compute the distance. We used a formula, Haversian formula.
You have not mentioned that formula in your project slide, no? So, how much distance is set in order to measure your neighbors or neighboring farmers or like that? Similarly, I have a query regarding the recommend. Is there any recommendation services in your project management module?
Uh,
Uh, I mean, we have implemented the searching algorithm in the way that the user's location is already there, and with the product details also the location of the latitude of the producers also is there, and with the product itself. So we can when we are searching or when the product is listing, the distance between these two uh, locations will be calculated, and then it will be sorted in an ascending order such that the nearest product will become to the user initially.
Recommendation system works is the same. The same
Yeah, because
logic is behind recommendation system.
we should be showing the uh, product with the least distance. So in the recommendation also, all the products will be listed, and if you are searching for a particular product, that product will be shown based on that distance also.
Okay, okay, thank you.
Thank you.
That was a meaningful discussion with some important takeaways. Thank you once again. Moving forward, moving forward, we have Shikha, Eapen and team presenting the paper ID number 33G on TrackEx, a comprehensive expense tracker with the stock recommendations and tax management. This research explores how technology can help individuals manage their finances efficiently. Let's hear more from the team. മിസ്സേ അത് ആദ്യം ഞാൻ ഒന്നും പറഞ്ഞില്ല നേരത്തെ ഞാൻ വിചാരിച്ചു ഞാൻ പിന്നെയും തെറ്റി അറിയാതെ വേറെ ടീമിനെ വിളിച്ച ഒന്നും പറഞ്ഞില്ല
Hello, all. Am I audible?
yes.
Yes, yes.
Hello, all. Good afternoon. I'm Shikha Eapen, and I'm very thrilled to present our paper titled TrackEx, a comprehensive expense tracker with tax calculation and stock recommendation, with paper ID 33G. And I'm accompanied by my teammates Gokul Srikumar, Mridul Chandran, and Shreyas Das S. So, our project, TrackEx, is an all in one financial management platform that simplifies expense tracking, tax planning, and short term stock recommendations while also providing a secure payment gateway for seamless transactions. So, the major challenge that we face now is fragmented personal finance management. That is, there are tools that exist even nowadays, but then that work separately for expense tracking, for tax calculations, and for investment recommendations. So, hence, users struggle to manage finances across multiple platforms. Therefore, we bring our solution as a one integrated mobile application called TrackEx. So our system has four main features, which is one is an expense tracking module, which provides real-time expense tracking, a tax calculation module, which provides a tax calculator that calculates tax based on your given income and applicable deductions, both in the new regime and old regime. And then we have a stock recommendation module, which provides tailored stock recommendations for short term trading. We also have a built in payment integration along with the expense tracker module to do any transactions or payments you want. So, coming to our expense tracker module, it provides an automatic expense categorization, a real time transaction monitoring, and also a secure payment gateway, as I mentioned before, to do your transactions. Coming to our tax calculator module, we have an automated income tax calculator that supports both the old and new regimes. So it helps users optimize tax liabilities and also compares the different tax scenarios and also recommends which regime is better for them to file their income tax returns. Coming to our stock recommendation module, we use an AI driven approach for predicting stocks. So basically, we take data from Yahoo Finance from the last 4 years, and then we give these data to the deep learning models such as CNN and by LSTM. And we pre-process it, and we also use an XGBoost ensemble method to predict the next day prices. Based on these, we give personalized investment recommendations. So this is our basic system architecture where we use a MySQL database to store the expense and login details. And we also use a Flutter front end for an intuitive interface for viewing their details such as expense details, their tax details, etc. We also use a Django REST framework for connecting the backend and the front end. So coming to our implementation, this is our login page. So if you already are a user, if you have an account, you can enter your credentials and then log in. And if you do not have an account, you can go to the sign up page and then enter your email, your username, your password, and to re-enter your password so as to confirm it. And then your account will be created. Once you are logged in, you reach our home page. Here you can view your bank account number, then the total number of days left in the month, and the total expenditure of the month. You can also view your balance by clicking on this I button. You have to enter your PIN, and then your balance will be displayed, but that is only viewable for up to 5 seconds. And then it will go back to this interface, and you'll have to enter your PIN again. So here we have 4 features, that is payment history, categories, and manual entry. And here you can view your last 3 recent transactions. So coming to the pay feature, here you can enter your recipient's account number, the recipient's name, the IFSC code, the amount, and your PIN. And once you click proceed, the payment will only be successful if the above entered details are valid. That is, if there exists an account number and the respective data. Otherwise, the payment will be failed. Coming to the next feature, that is the payment history. Here you can view all your recent transactions, etc. And you can also filter your transaction based on a start date and end date, and also based on specific categories. Talking about the categories, we come into a category details. So we have given 7 inbuilt predefined categories such as food, groceries, transportation, entertainment, utilities, education, and healthcare. Here we can also set a budget. That is, in the case of food, you've set a budget as 1,000, and if you spend over that amount, and you will get a message saying that rupees 370 is overspent. This is a manual entry. Here for suppose if you pay something using cash such as bus ticket, you can come here and enter your transaction details manually, such as the amount, the date on which it was paid, the category, and a category description, such as if it was transportation, then you can give something like bus ticket, and the payment method, and you can add these transactions to your database. This is a payment. This is our TrackEx Pay, which is a payment gateway that we've integrated. So here also you can select your category, the amount you want to pay, the payment method, and once you click on Pay Now, the Razer Pay API will be initiated, and you will be directed to choose your payment method, and then after your payment will be successful. And if it is successful, you go to your payment history, you can see that the payment was successful. If you initiated the payment but then decides to cancel it last moment, your payment history will show it as initiated but not successful. And then coming to back to our home page, we have a drawer that has two options, profile and logout. And while clicking profile, you will see your profile, such as your name, your bank account number, and you have two options to change your password and to change your PIN. And then you can log out and you'll go back to your login or sign up page. So the hardware requirements for our project is high performance workstations equipped with multi-core processors, which should be at least 60 GB RAM and SSD storage. The network equipment requires high speed routers and switches or high speed internet connection uh, for smooth access to Razer Pay API integration. The software requirements include an operating system of 10 or 11 Windows and development tools such as Visual Studio Code's Android Studio, database that we used for managing and storing user data, expenses, etc. are MySQL. And as I said, the backend framework is Django and the front-end framework is Flutter. So the result that we got from our project is automated financial management, and for users with limited literacy on financial and finance related terms, there has been an improved financial literacy. There has been real time insights, and for people wanting to invest on stock, they get personalized recommendations on where to invest their money. The conclusion, integrated solution for personal finance, leveraging technology for financial empowerment, simplifying financial decision making. The future scope, we can include a UPI and digital wallet integration. We can we can integrate it with real bank accounts for payment, etc. We have AI driven budgeting, tax filing support, and cross platform compatibility. Thank you.
An excellent take on financial planning and management. Thank you for your contribution.
We now open the floor for questions from our judges and audience.
Okay, you have done expense categorization. Am I right?
Yes, ma'am.
Yes, ma'am.
Which algorithm is used for this categorization of expenses? So there are different
Ma'am,
expense labels come, no? So which algorithm is used
ma'am,
for this categorization of?
Ma'am, currently we are using a database, and we have created a dummy bank database, and we are fetching the details on the database. While we are adding a transactions, we select the categories and categorize the expense based on the categories we have
How many
mentioned
categories
like
you
that.
have set in your? How many categories you have
Mm,
set?
we have currently set up 7 categories.
Okay. So when a new
Which
tax regime comes, who will make changes
uh,
in your software?
we have now created with the existing tax calculation that was implemented on the last year, but there are some changes
Okay,
in
okay. But
the new.
when the budget comes, new tax regimes mostly opens, no?
Yes.
So
So
who
if you
will
want to
make
change the,
modifications to new tax regimes?
yes, ma'am, we should do new modification when the new budgets come.
So you have to restructure or remodify the entire software when a new tax regime comes. Am I right?
No, no, ma'am, no, ma'am. Just only calculation. We just need to change the calculation. Sorry. That's now it's 5 lakhs, below 5 lakhs. We don't have the tax like that, but it was changed to 12 lakhs. So
So last time,
if the new,
before 2 months, there is a change in tax regime has come. Have you
yes, ma'am.
considered that in your project?
No, ma'am. The proper calculation is not yet out now. We will update only after the
Okay.
proper calculation scheme is available.
Actually, what I am asking is that
Uh,
during each budget time,
uh,
they will be introducing new tax regimes or new deductions like that. Okay, so when it comes, for example, next year there will be next new tax regimes come. So whatever you
uh,
have implemented in your project may be changed. Okay, so
yes, ma'am.
do
Yes, ma'am.
that? Who will do that new
We,
tax regime implementations in your
we
software?
should do that. Like
So you have
we
to
should update.
redo that thing.
Yes, ma'am. We have to maintain a
Now it
constant
is
updation
static
every
one.
year.
Okay, okay, okay. So there must be a
Ma'am, we are.
person behind this too in order to do that. Okay.
Yes, ma'am.
Okay, okay. Thank you,
Uh,
thank you.
A very informative discussion. Thank you for sharing your insights.
For our final presentation of this session, we have Aditi, Pradeep and team presenting the paper ID number 34G on Rapid Homes, a dual app solution for efficient on-demand home services and vendor connectivity. This study delves into growing demand for home service applications and vendor networking. Over to the team.
Hello, am I audible? Hello. Okay, so good afternoon. We are here to present our paper on Rapid Homes, a dual app solution for efficient on-demand home services and vendor connectivity. And our team members are Adi Pradeep, Akshara Vijay, Jerome Jo Mandra, and myself, KS Abhishek. And our guide is Jiti John. So these are the table of contents. And so basically, our project develops a dual mobile-based solution that connects a customer with local service providers for home maintenance tasks. The system consists of two apps, one for customer and one for service providers. The customer can submit their request with a detailed problem, and the service provider will give a response to them. So our problem statement is today we can see that whenever a customer faces a home maintenance problem, the customer will call a person who they already knew. So if that person is not available, then they can face a delay. So to avoid that, we are developing this dual app solution that connects customers with service providers in a real time, which ensures a fast, reliable service delivery and customer satisfaction. And it also includes a built-in rating system. So our main objectives are to develop a scalable platform to connect customers with local service providers for home maintenance, repair tasks, including on-demand and huge project services. So whenever a customer gives a service request, the service provider will give a response which includes a price and a time, and the response of all the service providers will can the customers can see all the response of the service providers, and they can choose from that according to their preferences. So this system also have the real-time notifications for service providers, and also has a message system so that they can connect actively and discuss their problems. And also one of our objective is to implement a secure transaction which is done by our escrow agent. We have done a lot of survey, almost 10 papers, and one of the most relevant two papers are one is web application based on demand home service system. In the system also, the customer has to register, they have to log in, and they can see the list of service providers, and from that they can select the service they want. But one of the main disadvantages of this that uh, in this admin have to assign the service request to the customer. So in this process, they can face a delay. So this is one of the main disadvantage of this system. Another one is HANAP Buhe, an Android Java-based mobile commerce application for freelance home service providers and client job seekers. In this also, this is like a freelance app in which the customers have to book services, and the service providers will give their services. And in this system, they have also implemented a secure payment via Stripe. Also, they have SMS alerts, but they do not have any chat system. So customer and service providers can't connect between them, and they can discuss the problem. So this was one of the main disadvantages of this system. So to overcome that, our system architecture is This is the user layer. It contains user layer. The users are customer and service provider. The customer will give a request. It will process in the server, and it will store in the database. The server will give that request to the service provider's app, and the service provider will give a response, which is in built-in services. The response contains a time and their service charge, and that service charge is also stored in database, and then the response is shown in the user's app. So there's a third party layer. If a customer want to see the location of the service provider, or the service provider want to see the location of customer, the server will access the third party layer, Google Maps platform, and after the server access the Google Maps platform, they can see the current location of the service provider as well as the customer. Also, there's an escrow account which ensures a secure payment, which is also a third party layer. And for in built-in services, after the completion of the service, it has a rating system, and also when the customers give a request, they have a recommendation system. They most efficient service provider will come first. So for software requirements, uh, the for developing purpose, Windows and Linux are used. Since it's a mobile app, both it supports both Android and iOS, and Chrome, Firefox, and Edge Safari are the web browsers. So in front end, we develop the front end on both Flutter, and Firebase is used for basically authentication and for notification system. There's an admin panel. Admin panel is only for monitoring all the service requests and the user accounts, which is developed in a Django template. And the API integration is used done by Dio. It is a Flutter package, and Postman is for testing and testing purpose for APIs. The backend is done using the framework Django, which is done by the Python programming language. We use MySQL database, and the backend is hosted on Python Anywhere. Python Anywhere is a cloud service hosting platform for backend, and the payment gateway we use is Razorpay, and the escrow agent is inbuilt in the Razorpay. So the module descriptions are first, there's a user layer in which the customer have to authenticate using a OTP, and then they have to fill their first name and last name, and then they can request a service. They can either give a description, a video, photo, or a voice, and then they can request a service. When the service providers receive this request, the service providers also have to authenticate using a OTP method, and when they receive the request, they can provide a price, their price and time, and after all the service provider respond to this service request, the specific customer can see all the service response. So they can, it's a like a bidding system, so they can see all the service provider response, and they can choose from that from according to their preferences. And the whole process, like the core layer manages the all data processing and service coordination, which includes the server and the database. The third party layer integrates with Google Map platform and escrow agents. Escrow agent, so the basically the use of escrow platform is when the service starts, the customer have to first pay the service charge. That amount will store on the escrow account, and after storing that amount, the service provider will start their work, and after completing their work, if the customer is satisfied, the payment will the payment will be credited to the service provider's account, and if they are not satisfied, the admins will interfere and the problems will be resolved within the 24 hours. So this it builds a trust and a secure payment transaction. So one of the main advantages of our system is competitive bidding. Multiple service providers can bid for a task, which allows the customers to choose the most cost-effective and suitable service. And also, this enables a transparent pricing and reviews. The service providers are based. The service request will receive the service request. The service provider will only request the service provider from the nearby location, which is done by the geolocation API provided by the Google Maps platform. And as I said, there's a secure payment which is done by the escrow agent. So coming to the results and output, this is the authentication page for the customer app. They have to fill the first name and last name, and then they have to create profile. This is the authentication page for service provider app. First, they have to add a profile image. Then they have to choose category like plumbing, electrician, like that. They have to enter their first name, last name, Aadhaar number, and they also have to upload a certificates. Only then they can start their service. If they did not upload any certificate, they cannot start their service. So this is a booking interface for the customer. From the request service button, they can request a service, and the map here shows all the nearby service providers. And once the service request is sent, the service request status is open, and whenever the customer accepts the service provider, the status of the request will be active, and when the request is complete, the status of the request will be completed. This is the payment interface, and this is the chat interface in which service provider and customer can chat in real time. So in our future scope, it can be expanded to new locations. It can be implemented in all over the India or world. We can implement an AI recommendation which suggests the best service providers, and also it can integrate with IoT devices. It can give automatic, if there's a fault in home services, it can automatically detect the problem and can send a request. And for conclusion, this dual app system ensures a efficient communication between user and service providers. It also ensures a real-time service request, enabling quick response and improving customer satisfaction. And also, it enables a transparent pricing and reviews, which enhances the trust and decision making. And these are the references. Thank you.
That was a fantastic way to conclude our session. Thank you for detailed insights and thorough research.
Let's now proceed to the final Q&A session of this track.
Why should you specifically choose escrow system for your payment gateway?
Uh, because traditionally we can see that if the customer is not satisfied with the service, they will begin bargaining and they can pay less to the service provider. So by implementing the escrow agent, we can ensure that the service provider get the accurate amount they specified. So it will, enhance the trust of service providers, and they can get more services from our system.
So you said that the customer will provide the nearby service providers. Am I right?
Yes.
So how many
Yes.
number of service providers you will provide at a time?
No, we are
Or
not
that
providing
distance
any.
is set? How the
We are not
distance is set to?
like we are first set it. The map will show all the service providers, but the service request will only send to the nearest service providers according to the customer location.
So the cost of that amount will not be considered, no? The cost for the
Which cost?
pricing of, suppose that is service provider will tag some price for the service to
Yes.
the customers, no?
Yes.
So that price constraints will not be considered.
No, that is a like an approximate price. Then they will discuss through message or in person. They can also contact and they can fix an amount. And before
All
starting a
these things through your
service,
app. All these connections
yeah, all
must be
these
through
things.
your app.
Yes.
Okay. 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 Thank you.
Thank you, ma'am.
That was a highly engaging and informative discussion. Thank you for your responses.
Before we officially conclude the session, we kindly request all participants, judges, and faculty members to turn on their cameras so we can capture group screenshot as a memory of this insightful session. Jai.
Thank you, everyone. We appreciate your cooperation.
With that, we conclude the track 3 of today's paper presentation session. A special thanks to our track chairs, Shanu Sir and Sabina Miss, and faculty in charge, Nasseena Miss, for their valuable time, insights, support throughout the session.
We also extend our gratitude to all our presenters for their exceptional research and thought provoking discussions. Your contributions are a testament to the innovative potential within our academic community.
A sincere appreciation to our judges, faculty members, and audience for their engagement and participation, making this session a truly enriching experience.
We hope today's discussions have inspired further exploration and collaboration, wishing all our participants the very best in their research endeavors. Thank you and have a wonderful day ahead.
Okay. This is a screen recording of a clear time.